Okay, so let's start. My name is Stefan Zimmermann. I'm working for Atos Global BMPS in the CTO office and being responsible for innovation in additive manufacturing. Therefore, I want to present to you today what Atos is bringing to the table in additive manufacturing. Our program called SOFIA, Solutions for the Industrialization of Additive Manufacturing. So in general, additive manufacturing is one of the major disruptive technologies in the future when it comes to manufacturing. As you can see here, the business figures look quite promising with a 380% overall predicted growth between 2017 until 2024. So the major advantages or business benefits that you have is in time to market with regard to rapid prototyping that you can do. Apart from that, also flexibility in the design that can be achieved by additive manufacturing, which is not achievable by conventional manufacturing. And therefore, a lot of companies have engaged in the industrialization and also in investing in additive manufacturing. As you can see here, there are a few screenshots taken from the press. We can see that different renowned companies are now entering into additive manufacturing. Our aim is to bring it from the current domains where it's quite prominently applied, like the design or the prototype printing, for example, in the product design process, to the industrial applications, and therefore bring technologies or create technologies around the monitoring and the analytics and the management of an additive manufacturing ecosystem and the simulation of additive manufacturing processes. So what is it that Atos offers? First of all, it's a threefolded offering that we have. The first offering that we can bring to our customers is the methodology for additive manufacturing, M4AM. Many of our customers have different maturity levels when it comes to the applicability of parts to be 3D printed. That is addressed by a maturity assessment where we say, okay, which of your parts are able to be 3D printed. We are also going into the proof of concepts and proof of values in order to evaluate the benefits, the economic benefits of it. As you can see here, for example, in an example in the upper right corner, you see a hook. That is a part that one of the customers is mass producing. And by just substituting the manufacturing technology by additive manufacturing doesn't bring a positive business case in that respect. So what we have done is we have optimized the part, as you can see in the right picture, meaning that we could save weight and that we could better also suit the part to be mounted in the environment for which it is destined, and therefore we have a better business case here and a positive business case by applying additive manufacturing. The major topics that we have is the Atos IT platform, which is, in short, managing the complete additive manufacturing processes and the network being own printer and printing capabilities, and also the ecosystem, meaning service providers, 3D service provider, printing providers that are part of the ecosystem of a customer, And finally, the predictive monitoring system, especially when you're in regulated industries, where you have certified parts and you need to stick to the certification parameters. This is a critical application where you can monitor the quality of the workpiece being produced in real time, and execute, for example, analysis like porosity analysis, which plays a major role in, for example, the manufacturing or printing of metal parts. So in addition to the platforms, we are also having some APIs and also inroads into other applications. So we can link, for example, our additive IT platform or manufacturing platform with MindSphere from Siemens. There's a connection kit available, and also AWS IoT, there's a connection kit available. We also have a cost calculator app where you can calculate the cost of a 3D part for own resources, but also for third-party resources in your network. We do porosity prediction in the predictive monitoring system. We also do thermal simulation and anomaly detection, that is map the actual KPIs against the to-be KPIs here and detect any kind of anomalies. So the platform itself has different functionalities. For example, companies, meaning we can create and manage our engineering partners, customers, factories, external printing services, or other stakeholders in different locations that make up, the additive manufacturing ecosystem. We can also integrate the companies within our ERP system, that is the related commercial workflows. The projects and sub-projects, we can create a hierarchy of projects and sub-projects where we can organize the additive manufacturing developments. And it's also able for our customers will also be able to integrate the hierarchy from their PLM system for full correspondence with the overall engineering into the system. Parts. Here are the parts uploaded that are subject for 3D printing or additive manufacturing, additive manufacturing here. We can create here a parts library, which also indicates the additive technology that is going to be used to manufacture the part, the material, and the underlying 3D file which is needed. If it's a certified part, we can also store the qualification requirements and also the assignment of the part to the projects and the sub-projects is done. Roles, there are different roles in the platform which can be assigned. For example, roles like part validator, parts requester, or the factory manager. The machines network, 3D printing machines network, we can create here the network linked to the companies, meaning our own factories with the capabilities, but also third party, where we can indicate the key features and capabilities of these partners. So saying, okay, which partner would be suitable for the manufacturing or the 3D printing of which parts. And also the technology and chamber size, for example, is also stored here in the application. So printing request, we can use that platform also to guide, to create the printing order and also monitor the printing order throughout, the manufacturing, 3D manufacturing process here. That is also, we can also indicate whether this is a part that is that is subject to certification, so that we can also say, okay, do a link or trigger the PMS, which is the predictive monitoring system, so that the system can monitor the workpiece and the quality of the workpiece during the printing job. We have two use cases which we cover with the platform. One is the production of new material, but there's also another use case which more and more gets popular. That is the production of spare parts, where the customer requires the right to produce spare parts on site. That is requiring that they collaborate with the OEM. For example, take an airline or an airline like Lufthansa wants to print their parts or major parts in the future on site in their workshops, and then they would go back to Boeing and Airbus and say, okay, please provide access to your PLM systems where the 3D models are stored. And in order not for the customer to cheat, we have implemented a blockchain component in here, which is tracing or ensures the traceability with the blockchain service. That is that the part or the number of parts will be tracked. Every part or project gets a blockchain ID that can be tracked, and therefore we can assure that only the parts that have been ordered or the number of parts that have been ordered are also produced. A word to the predictive monitoring system. As said before, we are tracking here the quality parameters and also the adherence to the certification parameters that the part might have. And that is done real time. So we are liaising or interfacing with the sensors that are in the printers. For example, from our partner EOS, but we are also working on the integration of other printer manufacturers like Renishaw or Stratasys, where we draw the necessary information from and data from, and then based on Atos Codex data analytics, put an algorithm on top where we drive the measured values against the to-be values in order to detect anomalies, and therefore that the quality manager can then take counter actions in case some parameters are not met. The other topic which is important for metal surfaces is porosity. The less porosity you have, the better the quality of the workpiece is. That is also something which we are monitoring with our system here. Yeah, especially in times of COVID-19, the additive manufacturing is important in order to partly cover disrupted supply chains. We all know that supply chains in the high season of COVID-19 were disrupted because the transportation sometimes was not possible, factories were shut down. And the idea behind that is to say, okay, I substitute, components and parts that I've procured by make them myself or use partners to manufacture themselves, and therefore bridge the gap from the disrupted supply chains. So therefore, we can assist our customers with our consulting offering, which is maturity assessment of the parts and components, and also the use case definition end-to-end here, and also the business case calculation. We can also, if that's positive, we also can implement the platform remotely, so we don't need to interact directly with the customer. This can all be done remotely based on provided CAD files, material data, and so on that is provided online or by email by the customer. And also the platform can be installed remotely on the systems of the customer. So we are also bridging still the travel bans that are in force with a lot of companies yet, and or still, and therefore can help our customers to manage, to better manage the consequences of the lockdown. Yeah, so our solution can be applied to many, many different industries and sub-industries, starting from medical devices, for example, if you have hip implants and so on. It is in the manufacturing of high-performance devices to demand, individual for the patient, but also when it comes to maintenance and spare parts, if we look at computer tomographs or other medical devices. In defense, where our customers can use this in the production of military products, but also in the field or on ships, where they produce spare parts on demand. Infrastructure the same, also on demand, for example, railroad networks and others. Industrial equipment, or also discrete manufacturing, machine parts that are printed on site, or machine parts that are in or 3D printed parts that are integrated in the design, new designs that are possible with additive manufacturing. Automotive is the same. A lot of automotive clients are heavily investing in 3D printing, using the first parts that are 3D printed. Also here, the service case is also, the spare parts case is also a vital one. Equipping, for the ideas of equipping service partners with 3D printers, and then creating a network where they can access then the 3D models in order to print spare parts. The same is true for energies and utilities. We have customers that say, okay, why should I procure, for example, parts for my gas turbine from Siemens or from GE or from Alstom, and therefore save on the inventory and also the cost of the inventory, and have it ready whenever I need it, and also forgive the long procurement times that I might have, and therefore also the lockdown of the equipment or the downtime of the equipment. Aerospace is also a similar case. Yeah, so the major benefits for products, that is for new products manufacturing. First of all, it's the redesign and performance simulation before you print. Yeah. Also the reduction of direct cost of testing the EM parts. It's also reducing the time and resources that you need for certification of the printed parts, especially by the predictive monitoring system. And you can also enable the traceability of the 3D printing process, also with third parties, and protect the IP of the part, and ensuring also that the parts are authentic and also safe. For the services, it's improving the time to service. For example, unpleasant downtimes of the equipment, because it takes maybe days or even weeks for between the ordering of the spare part and the arrival of the spare parts on site. It also reduces the storage, because a part that I can create from scratch does not need to be stored in an inventory, and therefore is not incurring any capital cost. You can also create a homogeneous network of 3D printing here. The same topic also here, the full traceability of 3D printed parts, that you avoid that your customer, from an OEM perspective, the customer is cheating on the numbers that he has ordered. And it also helped to increase the digital service catalog. And what is important is also that indirectly you also reduce your carbon footprint, because every part that doesn't need to be transported by ship, by train, by truck, or by any other kind of transportation means is also reducing the carbon footprint. Apart from the fact that you're gaining additional flexibility in not only the designs, but also in the manufacturing. And as we all know, the demands of our customers, be it in the B2C or in the B2B market, is becoming more individual. And with the more individual consumption, the lot sizes will go down. And that is an ideal base for 3D printing in order to be able to serve those demands. So thank you very much for joining this webinar. And in case you have any questions after this, you can address that either to me or to my colleagues. Thank you very much and have a good day. Bye-bye then.